So you are getting towards the end of this unit of finding slope and going through the 5 representations. In fact, you're going to do a review piece today, redo something that you've already done. So some of you are good at it, some of you are going to practice a little bit more. Either way, you're going to revisit getting a rule from a table. The second thing is Wednesday is a review and Thursday is a test. So this is table to equation, situation to equation, given representation, fill in the other representations. That's what your task is for today. But I'm going to go over this one more again so we can get better at it. So you have a table and I need to find a rule or equation. So it's going to be in the form of y equals mx plus b. And I need to find an m and I need to find a b. When I am looking at this, m means my movement or my slope or how change of y happens over the change of x. All three of those things are saying the same thing. So if I go here, I go from 7 to 4, I subtract 3. From 4 to 1, I subtract 3. From 1 to negative 2, I subtract 3. And from negative 2 to 5, I subtract 3. Now I can't just do one side, I have to do the other. That's add 1, add 1, add 1, and add 1. Okay, then the next thing is it's the change of y, which is negative 3 over 1, which is negative 3. So I have found my slope, or my movement, or my change of y over my change of x, or my constant rate of change. My b is always, it's called the y-intercept. That's the y-intercept. So I can say, hey, find me the y-intercept. And that is always in the form 0 and a number as a coordinate pair. Okay, so I'm going to look, he's right there. So that's 4. So then I just fill in my numbers for m and b. So y equals negative 3x plus 4. And that's my equation. And this is what I'm looking for. Now, remember, equations have equal sides. Repeat the process. From here to here, add 2, here to here, add 2, add 2, add 2. Do not forget to do the other side. Here it's add 1, and I'm going to look, and it's all the way down. So my m is 2 over 1, which is simplified to 2. Make sure you always simplify those fractions. My b, now there's a 0 here and a 0 here. We have to make sure that we know which one to go look for, and it's the 0 in the x. That's the y-intercept, which is negative 6. So my equation is y equals 2x minus 6. Now, there is no need to do a plus minus. In fact, that you'll have some points deducted. Okay, so go back and put that as a minus 6. Doing the same thing. Okay, so this one had a 0, this one had a 0. I'm just looking at this going, she forgot the zeros. But I can still do it. So this is plus 1. And I can glance down, and this is adding 1 each time. So I'm going to, that's my change of y. And this is plus 4. Plus 4, plus 4, plus 4, plus 4. Okay, so my slope is 1 over 4, because it's the change of y over the change of x. My b is not there, but I can create it. 8, I can go 20, 16, 12, 8. If I go down the tower, adding 4, I can go 20 minus 4 is that, minus 4, minus 4, and if I minus 4, I magically got my 0. Woohoo! So this is 8, 7, 6, 5, 4. The next number would be 3. Now I do. He might not be in the table, but he might be able to be created. And so that's 3. y equals, and because you're virtual, you're going to put your fraction in parentheses, x plus 3. And this is how you're going to do it. If you type in virtual, you will be counted off just a little bit because that is going to be something that I do not want you to get used to in virtual. So I want it in your fractions protected. Okay, here we go. One more. Couple more. 9 to 11, add 2. Add 2. Add 2. Here you're adding 3. You're adding 3. My slope is 2 over 3. So what I'm doing every time is I'm finding the change of y over the change of x. They are the same. Constant rate of change. And then I have to find my b. He's not there. But if I'm adding 3 to go down the tower, I can subtract 3 to go up the tower. So 6 minus 3 is 3. Not there yet. But if I subtract 3 again, I get it. So I've got to go 2 steps back. So here it's adding 2 to go down. Subtract 2 would be 7. And that would be 5. So here, he's a little bit outside, but I was still able to create him. It's 5. So y equals, protect my fraction, plus 5. Okay, if I ask you to write it, sometimes you're using your red or your yellow or your green and you're able to write on a problem, then it should look like this, where the x is either in the numerator or pretty high up. No question that it's not in the denominator. Okay, so this is if you write it. And that's okay if you write it. But if you're typing it into the computer, it has to be typed like that. Okay, here we go. Add 5, add 5, add 5. This is add 1, and I look, it's all the way down. So my slope, or my movement, or my constant rate of change is 5 over 1, which is 5. So make sure you simplify your your whole number fractions. B is right there. So B equals -4. So y equals 5x minus 4. If I ask for a rule or a function, I am actually asking you for an equation. One of the first things I'm looking at is whether you have an equal sign. Something else that you're going to look at today is which table is shown. There's lots of ways to do it. Okay, one, it's horizontal, and it doesn't go, most people make a mistake, so you could do exactly what I just did. But if it's multiple choice, you actually can use your answers. So I can go -2 times 0, because that's my input. That's 0. That's not 0. That can't be it. Okay? I can go 2 times 0. That's still 0. That's not it. I can say 2 times 0 plus 3. I'm inputting here. And I'm getting out that. And then I'm going to go 2 times, oh, that's 3, which that checked out. 2 times 1 plus 3, that's 5. That checks out. 2 times 2 plus 3, that's 7, and that checks out. If you're going to do it this way, you must check all the way down the table. Because what sometimes they do is they let the first couple work and then somebody down here doesn't work. The other way you could do it if you don't use your answers is you can change it. 0, 1, 2, 3, 5, 7, plus 2, plus 2, add 1, so it's a linear equation with the slope of 2 and the y-intercept of 3. So it is 2x plus 3, y equals. But please be careful on this. you can't assume that this is the y-intercept and go straight to here without checking the slope all the way down and all the values, because like I said, sometimes they will do that. Okay, you have two different problems that need attention to see the similarities and differences of the problem. Here's the picture. And in my mind, if I see this picture, if I'm in a slope unit, these are slope triangles. However, we just did a unit on Pythagorean theorem, and these are right triangles. So I have to read, and sometimes I don't, and that's what gets me into trouble. So here we go. The triangles are similar. Okay, it'll start out, the triangles are similar. What information tells you about the length of each triangle? Okay, so length, or the word distance, is the tip-off that this is a Pythagorean theorem problem. Okay, and that's when you would go find the leg, find the leg, find the length of the hypotenuse using a squared plus b squared equals c squared. Similar triangle says same shape, same angles, corresponding pieces are proportional. Similar does not mean same size. Okay? So if we're looking for distance and length, this is a different length than this. It's the word length or distance that'll tip you off that it's a Pythagorean theorem problem. If they say the triangles are similar, what information does that tell you about the slope of the line which creates the hypotenuse of both triangles and is part of the same line? Then we're calculating slope, and we're calculating slope. And the definition of slope is constant, so anywhere I calculate slope on a line should be constant and equal if I simplify the fractions. So if I use this one, if I calculated the slope between A and C, it's up to right 3, that's AC. And the slope of DF is up for right 6, that's DF, and that is simplified to 2/3, and that's the same. So you're going to have to pick slope, you're doing slope triangles. If it says length or distance, you're doing Pythagorean theorem. Make sure that you can look at a problem and know what they want you to do for it.